This is question number 34 from the June 2019 Regents. I want to first point out that it has a lot of words to it, so I'm going to use a strategy that I use on the test. Every time I read a number, I'm going to circle it. This way I can refer to the diagram afterwards and make sure all of my numbers are in the diagram. So this is just a way for me to make sure that when I'm reading all of these words, I'm not missing any new information that may not be already represented. So the question says, Nick wanted to determine the length of one blade of the windmill pictured below. He stood at a point on the ground 440 feet from the windmill's base. Using surveyor's tools, Nick measured the angle between the ground and the highest point reached by the top blade and found it was 38.8 degrees. He also measured the angle between the ground and the lowest point of the top blade and found it was 30 degrees. So as someone who has traveled cross country many times, I've seen many of these windmills, so this is kind of an exciting question because these blades are actually huge. Very deceiving to look at this picture, but huge. Whole size of a truck this blade could be. So when I'm looking at this, I'm first going to acknowledge those three measurements that I have and talk about whether they're in the diagram. So I do have that 440, that's in the diagram. Let me use a highlighter. So this is in the diagram already. This 38.8 is in the diagram. This 30 is in the diagram. I feel confident all my information's there. I see X. Now I know I have everything I need. So this question shows up quite a bit on the Regents in different forms. And when I say this question, I mean two triangles pieced together. Now there are actually more than two triangles here. There's three. But I want to remind you that in order to use a piece of trigonometry that we use often, so, ka, toa, we need to use it in a right triangle. So this is called right triangle trig. We can only use it with a right triangle. If you don't know how to use SOHCAHTOA, you don't know how to label a triangle, you don't know how to find a side or an angle, look for other videos in the channel. There's plenty of videos to help you learn how to do that. But for this video, I'm going to look for right triangles. So in my hunt for right triangles, I see the whole big triangle. That is a beautiful right triangle. Okay. I also see a smaller right triangle here. While there is a third triangle, and I'll point it out, this guy over here, it is not a right triangle, so I can't use it for this problem. So I'm just going to be using that pink triangle and that green triangle. I often find with diagrams such as this, it's a lot easier if you redraw those triangles. So I'm going to redraw my pink triangle over here and my green triangle over here. And I'm going to put all the values that those two triangles hold. So first and foremost, I want to point out where my right angle is, right here in each of those. In my pink triangle, I know that this is 38.8 degrees. I know that the bottom of that triangle is 440. Now, if I take a look at the green triangle, I know that this angle here is 30 degrees, and the bottom is 440 as well. So notice in neither of these triangles do I have X, because X is over here and it's not a part of either triangle. So it's really important when we're doing situations like this to take a look at the overlapping. They want to find that X, but that X is a piece of the pink. It's not a full piece. But if I find this full pink side and I find that full green side, so let's take a look at this. If I find this full pink side and I find this full green side, I can subtract them to get X. So I'm going to be looking for this side in both of these triangles. And then at the very end, subtraction is going to help us to find our actual missing value. So let's put this down here. I'm going to put, don't like to use the same variables, so that's X up there. I'm going to call this, let's call this A, and let's call this B. So in the end, X is going to equal to A minus B. I just have to find A and B first. So again, there are videos in the channel that can help you learn how to label triangles. So I'm going to move a little quickly right now, but please check out those videos if you're unsure. When we are using right triangle trig, this is the angle. The hypotenuse is always across from the right angle. So that's the hypotenuse here. And then we use the adjacent side to make that sound, squeezing the angle. And that means the other side is our opposite. I'm just going to put OPP over here. Now notice our hypotenuse is not being used in this case. There's no number or letter with it. I'm going to be using my adjacent side and my opposite side. Now, if I take a look, I know I wrote SOHCAHTOA on the top. I'm going to write it over here again. SOHCAHTOA. The one that uses opposite and adjacent is tan. These questions, when you have the two right triangles, typically always use tan. Don't hold me to it. They can get creative, but tan's a nice safe bet if you're unsure. So I'm going to list this as tan. And in tan always goes the angle. So I'm going to put 38.8. And tan is equal to the opposite over the adjacent. So the opposite in this case is my A, or my variable, and my adjacent is 440. Now a good strategy I like to use is putting tan over 1 so that I can cross multiply. And when I cross multiply here, I get tan of 38.8 times 440, and then I get A times 1. So I'm going to do A times 1 first, and then I'm going to do tan of 38.8 times 440. Now I know that A times 1 seems kind of silly because that's just A, but it's really important to me that you think when you cross multiply, because often there can be some algebra involved that you need to think about, and if we're mindless, it doesn't really help us. So now I'm putting in my calculator exactly how I see it. Tan of 38.8. I'm closing that parenthesis. I'm multiplying it by 440. So those parentheses are very important. It's also very important, I'm going to put it over here in pink, to be in degree mode. So that's in the top corner of your calculator. You want to make sure you are in degree mode. Okay? So once I enter that in, it is going to be 353.7690827. And I did the little about symbol because I'm estimating it is an irrational number. It'll go on forever. And I'm putting that number there, but I'm going to use that unrounded number in my calculator when I'm ready for it. Now I'm going to put a line down here to keep myself organized. And now I'm going to solve for B. So over here, I'm going to relabel my triangle again. My hypotenuse is the first thing I label. Then I go, to get this angle. So that means that the two sides of this angle squeeze in. This is this is my A. And then my opposite is over here. Okay? So again, I'm using my adjacent side and my opposite side. And I told you that would often happen with these examples. So this is, again, a tan ratio. So this is tan of 30 degrees. And that's going to equal my opposite, which is my B, over my adjacent, which is 440. And I'm going to put that tan over 1, so it is a proportion. So when I cross multiply, I get B times 1. So I'm going to write that B times 1 equals, and then over here, when I cross multiply, I get tan of 30 times 440. So in this case, it's B equals, so now I'm taking my calculator and I'm entering tan of 30 times 440. And I get, and I'm going to undo that equal sign and do an approximate. This is 254.03411184. So now I know how big A is, I know how big B is. My final step is just to subtract. So remember, we said that X is equal to A minus B. So that means X is equal to this 353.7690827 minus this 254.03411184. Now you have a very fancy calculator, so you're going to be able to use these numbers and not have to retype them back in, but unfortunately I am not on a fancy calculator, so I am going to type them in by hand. So 353.7690827 minus 254.03411184. And if I hit enter, I get X is equal to, and I'm going to do an about, 99.7349643. So I always write my unrounded number because I want to make sure that if I make a rounding mistake, the person grading my Regents knows that's the only mistake I made. And I'm going to go back and see how they wanted me to round in this example. It says to find x to the nearest foot. So now I'm going to go back, knowing that I want to round this to a whole number. This 7 can change that 9 to a 10. So we have to think about this. This is 99 rounded up, 99.7 rounded up to the nearest whole number. And this is going to be 100. So 100 is my answer. I am not going to put feet. I am not going to circle it. I'm just going to write it at the bottom of my page. Because remember, on the Regents, we don't circle things. We don't put units because it provides an opportunity to make a silly mistake. And we just want to be nice, clear, and concise. Again, this question shows up a lot. So if you see two triangles, find your right triangles, use tan, and then see how to get the value they're looking for.